And we reserve questions for our current presenter at the end. And we can appreciate if you can put your questions on a piece of paper so that we can summarize his answers as the other presenter goes on.
So good morning, everyone.
Good morning.
In this presentation, I'm trying to follow up on what I presented on Tuesday, and I will just show you some consideration that drove us in the development that I'm going to show you. Then I'll present you the so-called Science Gateway paradigm, architecture, authentication, authorization, access workflow, and the grid engine, which is a way to interact with the middleware in a middleware-independent way. Then I'll show you some examples of science gateways in actions, and then I'll draw some conclusions. So the starting point is the same figure that I showed on Tuesday, but now the question is different. Are 20,000 users worldwide a big number? I mean, given the huge distribution of the computer centers building the E-infrastructure. So we wanted to compare, we wanted to analyze these figures. And of course, the first figures, the communities you want to compare, EGI, I mean the scale is logarithmic. So the EGI number, the number of people belonging to identity federations, the number of users of the GEN network in Europe, and of course the largest community you can think about, which is the number of users, of unique users of the social networks in the world. So there is a striking difference between the number of current users of the community, for example, and the number of users of the network. Then if you compare the funding, these are official numbers, official figures from the Commission. If you look at the FP6 and FP7, the 6 and 7 framework program, the funding, the fund spent in the network and in the grid infrastructure is more or less the same scale. So if you compare the funding with the number of users, you conclude that so far, the grid infrastructure haven't been so far a very good investment in terms of cost per user. That's the problem. So the reason for this is that using the grid is not straightforward. At least it's not straightforward for non-IT experts. When you come closer to the internals of the grid, you have to do with the command line interfaces, with script languages, and you also have to learn a language to describe your job and send the job to the grid. And as I underlined yesterday, and that has not been said today, you also have to have digital certificates, to keep the digital certificates, to transform from one format to the other. So the learning curve, the first step in using the grid is actually the hardest one. And this is keeping away lots of users from the adoption of this computing paradigm. There is another consideration. People in the GI, in the European grid infrastructure, and the other infrastructures in the world are grouped into what we call virtual research communities. And the integral of this card on the left is 20,000. But there are hundreds of thousands, millions of users somewhere, which do not belong to any virtual research community. They don't even know that there are virtual research communities. So the problem is how we can attract them, how we can let them use the infrastructure. So can we increase the number of potential grid users by a factor of 1,000, for example, opening to identity federation? Or even by a factor of 25,000, opening E-infrastructure to all the potential members of the social networks. So I'm trying to, in this presentation, I'm trying to present a model and an implementation that we are trying to answer this question and to reach this objective. So in the word, a new paradigm to access the infrastructures is becoming important. It is called Science Gateway. So a Science Gateway is a web portal, basically domain-specific, that hides the complexities of the network and let people belonging to the same community, to the same virtual organization, access the shared applications and execute them on the infrastructures. So we decided to build a new kind of science gateways, because the science gateways which are available in the world are not interoperable and are in many cases e-infrastructure specific. They work for one infrastructure, but they cannot be moved to another infrastructure or re-implemented to another infrastructure. So our primary requirement was that building science gateways should be as easy as building Lego toys. Why? I mean, if you look at the Lego brick, that's simple and that's standard. So that's two important properties. You can combine in very simple things, you can combine in more complicated things, and you can even do even more complicated things, but still the same bricks, standard. So, compare the Lego bricks with the science gateways. If you manage to decouple, to build a science gateways using bricks, then you can rearrange the bricks in several kind of toys, and you can adapt the toys to the different kind of virtual organizations. So the requirements that drove us in the development of this new kind of science gateways are standards, simplicity, easiness of use, and reusability. Once you have a brick, you can build a car, or you can build a train, an airplane with the same brick. So the reference model we have, so we have people belonging to different kind of organizations and having different roles, access a portal, and through this portal they can access the applications, and through a series of grid services they can run the applications on different kind of middleware, because as the speaker who preceded me said, the middlewares are different and the middlewares are evolving. Each middleware is evolving. So we adopted the LifeRay Community Edition as a portal framework. LifeRay is a very known software. Is released in open source. Only the support is commercial, and it combines portals functionalities, CMS, e-collaborations, and social software. But more importantly, it complies with the portlet standard, GSR 168 and 286. So in our context, the portlets are the Lego bricks. So we want to create our portals using the portlets and reuse the portlets from one portal to the other. The authentication and authorization schema is the most important issue, how we can attract the widest number of potential users. So we decoupled authorization and authentication. When people register to our science gateways, for the authentication, we rely on identity federations. And for the authorization, we rely on a local LDAP server where we can manage privileges and role of each user. And for the identity federations, we are supporting several identity federations, but more importantly, we built a catch-all identity federation to let people do not belonging to any federations to still be able to use the portal. And inside this catch-all identity federation, so we developed a special identity provider that bridges the identity federation with the social network credential providers. So identity federations I already showed on Tuesday. I want to underline one of the use cases of the identity federation, which would be very important, and where Europe and US and the Asia Pacific are investing, which is EduRoam. EduRoam basically is a worldwide roaming access based on radius and identity federations that allow mobilities across continents. Students and researchers can connect to the Wi-Fi campus independent of where they are, using the same credentials. So that's a very important thing. I discovered that there is an EduRoam access point in South Africa, but according to the map, this service is not available in Africa. And adopting the identity federations should be something that would ease the life in mobility of the researchers and students. So this is an idea of the identity federation. This is the Italian one. 50% of the Italian researchers and students have an e-identity, and in other countries of Europe, even 100% of students and researchers have an e-identity. So bridging the identity federations inside the portal is a way to have a huge number of potential users. So this is the catch-all identity federation that we created, called Grid Identity Pool. And so we have the two special, we have a catch-all IDP, and then we have this bridge to the social networks. So this is the workflow. So people goes to one of our science gateways. He asks for a registration. Then there is the science gateway manager or the scientific board of the projects of the community which is operating the science gateway that decide if the users has to be granted or denied. In case it's granted, the credentials of the users are stored on an LDAP server according to the roles and privileges that he or she must have in the portal. Then, in the second step, the user can sign in. When he signs in, for the authentication will redirect the portal redirect the users to the access page of his identity provider. He is authenticated. Then we check if the user is present in the LDAP server, and we check the privileges, and then we use a special kind of digital certificates, which are called robot certificates, which are associated not to a user but to an application, and they are stored physically on USB keys on the machine where the portal is running on. So the portal creates a proxy certificate on behalf of the users, executes the actions on the grid, and the user can get back the output. Of course, we track the users because one of the things that we need to ensure is the non-repudiability of the transaction. So we have a tracking database, and we track each transaction for the user. And this is required by the EGI portal policy. So concerning the interface with the grid, the Open Grid Forum, one of the standardization organization in the grid world, has defined a standard protocol to interact with the applications on a grid infrastructure in a middleware independent way. This is Saga, and Saga is a standard, and there are several implementations. We adopted JSaga, which is based on Java, which is the best language to interact with the portlets and with the LifeRay framework. So basically what we did, we developed a grid engine. A grid engine is an API that allows the portal to interact with the different middlewares for the job management, for the data management, and has the functions to track the users in our tracking database. So basically, JSaga has different adapters for the different middleware. You program in the API which are middleware independent. So even if you want to move your science gateway to one infrastructure to the other, you do not have to touch the core software of your portal. You just need to change or to adapt the adapter. We developed 9 science gateways which are service providers of our identity federation. And we also developed this special bridge. So basically what happens when you get authenticated, the system moves you to the login page of your social network, you insert your credentials, and then you go back to the portal authenticated. I will show you in a moment how this works.
4 minutes.
Yes. So some examples. The first example I want to show you is the Indicate Cultural Science Gateway. Basically, this is a digital repository for cultural heritage data. So you go to the portal, and people can either log in or register. So in the registration, you can even say which is the identity federation you belong to, or if you don't specify anything, you are enrolled in our K-Cho Identity Federation. So when you try to sign in, you choose your identity federation, and according to the choice, you are redirected to the login page of your identity federation. There are two examples there. Or in the case you choose the identity breach, you choose the social network you belong to, you are redirected to the login page, and then you go back to the portal with the authentication on. So then you can navigate, you can browse the digital repository. This is, we have 3 repositories, and you can select the documents. You can inspect how many copies of the documents are around on the grid, and you can download and inspect them. And we have several repositories also on different languages. Of course, this is a framework where you can store, when you create and manage digital archives, very general. I mean, this is the cultural heritage, but we have the same kind of archive for medical images and also for satellite data. Other science gateways, so you see very simple web interface. The experts of the applications just have to insert the data. They know the input data, and then they get back the file. This is Gate application is a very known packages to simulate radiogenic machines for radiotherapy, and this has been deployed on the Human-Grid Science Gateway. Phylogenetics on Gisela, the Latin American grid infrastructure. Again, very easy web interface. You put your input data, and then you get the output. The site, which is about the site is an European project that aims at creating an infrastructure to run applications for the early diagnosis, for the markers of the onset of the Alzheimer's disease. So you have several applications. For each of them, you have an interface. You select your job. You get back the output when the job is finished, and you can then the physician or the neurologist can do the analysis. We also developed a data manager. Images are anonymized, they are encrypted on the fly, they are stored or replicated on different storage. And all these interfaces is available through the Science Gateway. So people do not need to know how to interact at the low level with the grid. Science gateways are not only for scientific applications. We are developing a gateway also for e-collaboration. Basically, we wrap the very well-known Adobe Connect e-learning and the video conferencing system, and people can collaborate and share applications, the screen, the documents, can disseminate, you can book your video conferences, you can book your training, your lectures, and then you can even drive your courses from within the Science Gateway. Of course, this is a brick, so we can pick up this brick and put in one of the Science Gateway that I showed before. So we are going to integrate this system, for example, in the Gisela Science Gateway or in the Human-Grid Science Gateway, so that people, they can not only interact with the applications, but they can also collaborate with their colleagues worldwide. So let me summarize. Science gateways, identity federations, and social networks can change completely the way grid infrastructures are used, because basically we open to the the largest number of potential users. Basically, hundreds of millions of people can, in principle, access our science gateways. Of course, we can fine-tune the authorization. We can, in each case, we can say who and with roles and privileges. But the potential user base is enormous now. So the adoption of standards. So we try to build the science gateways only on standards. JSR, SAGA for the application interface, SAM for identity federations. And this represents a concrete investment towards sustainability. Projects and standards survive. So if you base on standards, then your products can be supported also by other communities in other contexts. So the problem now is that we have lots of potential users, but we need to develop tools and ways to attract them. a new kind of marketing from one side, scientific marketing, and from the other side, we need to think about new generation of applications. Because for sure, there are no millions of people interested in any of the scientific applications you may think about now. So we need to think about a new kind of applications, general purpose applications to attract users. Also the general public, what the European Commission calls the citizen scientist. So if you want to integrate your applications in our science gateways, or you want to learn how to create your own identity federations and your own science gateways, you simply have to contact me or to send an email to this mailing list, and we will try to support you and to help you develop in the applications. Thank you very much.